Hey everyone, it's Mr. Kabbalah. This is a video on unit number 8, lesson number 3, solving trig ratios. Now, please note that this isn't an eMath instruction homework. This is a homework that I made up. To access it, go to the Google Drive that has been linked in Google Classroom. So again, it's not an eMath instruction homework. You can skip that one for 8.3 and just do this one. Hopefully this is a help. Let me know if you have any questions.
Okay, this is the homework for 8.3. Please notice that it's not from eMath instruction. This is one that I created. I think it just does a better job of going over the more important things that 8.3 goes over. So this is about trigonometry and setting up and solving trig ratios. And the calculator does a lot for us. That's why it's very, very important to know how to set up a trig ratio and which one to use. So the first part of this goes over just setting up the different trig ratios. So kind of review, it says write the given trig ratio as a fraction, so tan of z. So here's z, here's z, right? And tangent, so we're going to use SOHCAHTOA, SOHCAHTOA. So for tangent, we need opposite and adjacent. Okay, so I again like to find the hypotenuse across from the 90-degree angle. Z is our reference angle, so the side opposite Z would be XY, which would make ZY the adjacent side. So we want opposite over adjacent, which would be 21 over 28. And if we divide both top and bottom by 7, we get 3 over 4. Now we could change that to a decimal, be 0.75, but it just says right as a fraction. All right, next one, cosine of C. So here's C, our reference angle. Here's our hypotenuse. Across from C is the opposite side, and then that would make BC the adjacent side, and we want cosine C. Cosine is adjacent over hypotenuse. So adjacent 16 over the hypotenuse 34, and if we divide by 2, we get 8 over 17. Now I think you could just leave it 16 over 34, but it's always good to reduce your fractions. All right, number 3, sine of A. So here's A, our reference angle. Opposite the 90-degree angle is the hypotenuse. Okay, going across from A, we get the opposite side. And then next to, and not the so next to but not hypotenuse is adjacent. So sine of A, we're doing SOH, S-O-H. So opposite over hypotenuse, which would be 32 over 40. And again, it's good practice to reduce your fractions. We could divide by 8 and get 4 over 5. And then this last one here, or number 4, last one on this slide, tan of C. So here's C. Opposite the 90-degree angle is the hypotenuse. Opposite or across from angle C is the opposite. And then that makes this side BC the adjacent side. And for tan, again, we need OA. So opposite over, so this is tangent of C. Opposite is 27. Adjacent is 36. And we can reduce that. If we divide both top and bottom by 9, we get 3 over 4. All right, and then next, there we go. Find the value of the given trig ratio as a decimal rounded to the nearest 10,000th. So just so we're all on the same page, there's the ones spot, or the whole number, tenths, hundredths, thousandths, 10,000ths. So we're talking about 4 numbers after the decimal. So let's do number 5, cosine of C. So for these, you gotta know your trig ratios. So SOHCAHTOA, cosine is adjacent over hypotenuse. So in this case, there's a 90-degree angle. Across from it is the hypotenuse, which is 45. Angle C is here, so opposite that is 36, which makes this BC adjacent. So again, for cosine, we need adjacent, which is 27, over the hypotenuse, which is 45. Now what we're going to do is go to our calculator, and we're going to type in divided by 45 and round to the nearest 10,000th, which, can you see that? There it is. Just gives me 0.6. So if we round to the nearest 10,000th, it would be 0.6000. All right, for number 6, we need, so I'm sorry, the cosine of C is equal to that. All right, so for number 6, tan of C, so there's our reference angle C. Across from the 90-degree angle is the hypotenuse. Opposite the reference angle is opposite, and then we have adjacent here. So for tangent, TOA, so that's opposite 12 over adjacent 35. So if we type in 12 divided by 35 on our calculator, we're going to then round that to the nearest 10th, so 0.3429. 0.3429. So I rounded that 8 up to a 9. All right, now here's where we need to, step number 1 is figure out which trig ratio to use. And then step number 2, use it as a proportion to solve for x. So for number 7, we want to find the missing side. Now they give us the 90-degree angle, so that makes this side the hypotenuse. So the hypotenuse is the side we're trying to find. 72 is this angle here, so our reference angle is the 72-degree angle. Across from it is the opposite. Now there's nothing written there, but I'm still going to label it opposite, which makes the 6 adjacent. So the two sides that are labeled for us are the adjacent side and the hypotenuse. Adjacent and hypotenuse. The trig ratio that uses adjacent and hypotenuse is cosine. So the cosine of 72 is the adjacent 6 over the hypotenuse x. Right, so adjacent hypotenuse. I'm going to put the cosine of 72 over 1. Remember that cosine of 72 is a decimal, so it's kind of like putting a decimal over 1. Then we're going to cross multiply. X times cosine 72 equals 1 times 6, which is 6. Then I'm going to divide by the cosine of 72, kind of like dividing by a decimal. We get x is equal to, then we go to our calculator. So 6 divided by cosine 72. And I think it said round to the nearest 10th, so 19.4. All right, in the next one, this is number 8. Here's our reference angle 37 degrees. Across from the 90-degree angle is the hypotenuse. Notice there's nothing labeled there. Across from the 37 degrees is the opposite, which leaves the adjacent right next to the 37 degrees at 12. So we are given, or we are labeled, or it's labeled for us, the opposite and adjacent, OA. The trig ratio that uses O and A is tangent. So the tangent of 37 is equal to opposite x over adjacent 12. Make that look like a fraction. I'm going to put it over 1, cross multiply. 1 times x is x. 12 times tangent 37. Okay, and saying tangent 37 is like saying 12 times 0.2359 or something like that. It's a decimal. And then the calculator does the rest. 12 times tangent 37. 12 times tan 37, rounded to the nearest 10th, 9.0. All right, number 9, kind of similar situation. All right, here's our reference angle 15. Opposite the 90-degree angle is hypotenuse. There we go. Across from the 15 degrees is opposite. And then that leaves. Now the sides that are labeled for us are opposite and hypotenuse. So sine uses opposite and hypotenuse. So sine of 15 is the opposite 16 over hypotenuse x. Put this over 1 and cross multiply. 16 equals x times sine 15. Divide by sine 15. And that's going to cancel those out. I'm going to put the x over here. So x equals 16 divided by sine of 15. On my calculator, I get 61.8. All right, number 10, 21 is our reference angle. Across from the 90-degree angle is the hypotenuse. Across from the reference angle is opposite, which leaves the last side as adjacent. So we are labeled for us our opposite and hypotenuse, so it's going to be sine again. So sine of 21 equals opposite x over hypotenuse 22. Put this over 1 and cross multiply. X times 1 is x. That's sine of 21, by the way. So on my calculator, I'm going to do 22 times sine of 21. 7.9 rounded to the nearest tenth. Okay, moving along. Number 11, 45 degrees. This is the hypotenuse. This is opposite, adjacent. We've got opposite and hypotenuse, so it's sine. $49.5. I get 41.1. All right, now for the, I believe it's going to go on, and it's going to have all three. I might as well just wait and see. There we go. All right, these are using inverse trig, so sine of b equals 0.4848. Just, I don't want to like make this too difficult, but basically what this is saying is that if we have an angle here, let's call it b, then the sine, the opposite over hypotenuse, if the hypotenuse was 1, then the opposite side would be 0.4848, and so on. Right? That's what that's saying. So what angle allows that to happen? Well, to do that, we need inverse trig. So sine to the negative 1 of 0.4848. And you could have decimals right in this section. You could also have fractions, because fractions can be turned into decimals. And then it's just calculator work. It would be second sine of 0.4848, and it's going to tell us the angle, and we're going to round to the nearest degree, so 29 degrees. All right, for number 14, A would be the inverse of cosine of 0.7431, and then calculator. 42. And then number 15 would be W is equal to the inverse tangent of 19.0811. And what is it? 19.0811. 19.0811. 87. All right, now we're going to put a picture with it, I believe. So again, these are cases where we'd have to know which trig ratio to use. So they are asking us to find this angle here. It gives us, so the hypotenuse isn't labeled. The across from our reference angle is opposite. And then next to it is adjacent. So we are labeled for us are opposite and adjacent, so this would be tangent. So tangent of, let's call it x, is equal to 9 over 21. So x would be the inverse tangent of 9 divided by 21, whatever that turns out to be. So on our calculator, we could find the decimal, 9 divided by 21, okay, and use that, or we could just do, what was it, inverse tangent of 9 divided by 21. 23 degrees? Does it say? Yeah, 23 degrees. Okay, for number 17, reference angle here. Cross from the 90-degree angle is the hypotenuse. Cross from the reference angle is opposite. So that makes this adjacent. We are labeled for us are opposite and hypotenuse. So SOH, so it's sine of, let's call it x again. Opposite, 12 over 24. So x would be the inverse sine of 12 over 24. Calculator. 30 degrees. All right, we got reference angle opposite the 90-degree angle. There's our hypotenuse. This would be opposite. This would be adjacent. So labeled for us are adjacent and hypotenuse. That's cosine. Cosine of x is 6 over 8. So 41.4, or just 41 rounded to the nearest degree. And then the last one on the slide, reference angle here. Now, if you take a look, for this one, you can pick what you want to use because all three sides are given. So let's do, what have we done so far? We've done tangent, sine, and cosine. Let's do sine. So sine of x, so you could choose cosine, you could choose tangent, would be 51 over the hypotenuse 85. Obviously, if you choose something other than sine, it would be a different ratio. So 37 degrees. All right, and then for the last one, I kind of drew a picture already. It says to draw and label the three sides of a right triangle that has a hypotenuse of 10 and an angle of 40 degrees. So here's my picture so far. Obviously not to scale. Now we want to get the other two sides. I'm going to try to show you quickly a couple ways to do this. Let's first use, we need at least one trig ratio to solve. Let's solve for this side here. So that's opposite the 40-degree angle. So I'm going to use sine of 40 is equal to opposite x over hypotenuse 10. I'm going to put this over 1 and cross multiply. I get x is equal to 10 times sine 40. So when I solve this, I'm going to get the length of that one side, the opposite side right here. All right, so 10 times sine 40. 10 times sine 40. Let's go 6.4. Right now, we could do one of two things. We could either, now that we know two sides of a right triangle, we can use the Pythagorean theorem. Okay, here's the hypotenuse. We could subtract off the side we just figured out and square it. We could do 10 squared minus 6.4 squared. So 10 squared minus 6.4 squared. Let me show you my calculator. And then take the square root of that answer. And our other side should be right around 7.7. So the square root of 59.04. So 7.7. All right, now another way to do that, and I'll kind of change color here, is you could do another trig ratio. So again, let's imagine we don't know it's 7.7. We'll call it maybe not x. How about y? We already used x. So this would be the cosine of 40 is the adjacent side y over 10. And then if you cross multiply, you get y is equal to 10 times cosine 40. And I bet you when we do this on our calculator, we'll get something close to 7.7. 10 times cosine 40. Hey, would you look at that? 7.7. Now the reason why they're not exactly the same is that I rounded this right here. So I rounded it to 6.4, and that kind of made this round a little differently. So 7.7. Okay, and that's setting up trig ratios and then solving to find a missing side using inverse trig functions to find missing angles. So hopefully this was a help. Let me know if you have any questions, and take care.